right, well, I guess I'll get started. So today I'm covering increasing, decreasing, and constant intervals. And this is something that is going to be on your quiz and on the final exam. So let's just review functions because that's what we are analyzing this week. A function is a type of relationship where for each input, there's only one output. So if you plug a number in, you only get one answer out. If we have an equation and it's also a function, instead of using y equals with our equation, we'll replace it with f of x. So that's f parenthesis x parenthesis. We read that out loud as f of x. It's telling us x is the input. F is the name of the function. And this is not multiplication. So you're not solving for x, you're not solving for f. We're not solving here. When we're working with functions, we're generally only working with the right side. So that's the basics of functions, and functions are specifically things that we like to look at graphically. That's just, how we use it most of the time. So increasing, decreasing, constant intervals. So suppose, I have added an extra letter here. Pretend that D is not there. Suppose that I is an interval. So just a section of your graph over X. When we're talking about our intervals, we're always looking at what parts of the X are we looking over. And so it says an interval contained within the domain of a function F. That just literally means we're looking at a section of X on our graph. F is increasing in this interval if the value F of X1 is less than F of X2 for all X1 less than X2 on I. What this basically means is that when we look at the graph going from left to right, it's getting higher as we move from left to right. So we always look at graphs going left to right. So if it's getting higher as we move left to right, it's increasing. If it's getting lower as we move from left to right, it's decreasing. And then if it stays the same as we move left to right, that's constant. So that's essentially what the math definition is saying here. So we're just looking, is it going up? Is it going down? Or is it staying the same? And when we're looking for the intervals at which this occurs, we always give the areas of the domain. So we don't give the y values. We're always giving the x values over which these things happen. So we're just going to do several examples with graphs to talk about increasing, decreasing, constant intervals and how you would give your answer. So use interval notation to write the intervals over which f is increasing, decreasing, and constant. So we will start with increasing, which I will do in yellow. So where are we going up as we move left to right? So that is this section of the graph, which as I highlighted, it's turning green, but that's the section that's going up as we move left to right. And then after that, we go down and then we're staying constant. So we want the intervals, we want what x values that is occurring on. So if I'm looking at where my graph is, it's in this interval that I'm highlighting on my x-axis. That's where our graph exists. Now the arrow that we have on the left side there, a little bit beyond -4, that means it keeps going to infinity. So that arrow is meaning that we're going to keep going towards infinity here. But then we stop when we hit 4. Now at 4, we're part of an increasing section, but it also starts to decreasing. So when we're doing these intervals, we never use brackets. We always use open intervals. We don't use brackets because the endpoints are both, because it's changing. It's in the increasing and the decreasing. So we're doing open intervals parentheses. So that means we're going to have a parenthesis here at 0, and then we're going to -infinity. So when I translate this into a number line, so I make my number line here on the x, we've got 0 here, and what I've just graphed is we've got a parenthesis at 0, and then we're increasing in the section to the left of 0. all the way to negative infinity. So you translate that into your interval notation, and we always read interval notation left to right. So the left side is at negative infinity, and that always has parentheses. And then we stop shading at 0, which is going to have a parenthesis, because increasing, decreasing, and constant, you're always going to be looking at parentheses here. So that's increasing. So now I'm going to switch colors. And let's do decreasing. So let's do that in green. So we are decreasing. Where are we going down? Well, our graph is going down in this very small section, basically on the x between 0 and 1. So right, that little tiny section right there. And then that's the only part it's going down. So I'm going to write my number line here. We have negative infinity to infinity, and between 0 and 1, I keep picking the wrong thing when I'm switching. So between 0 and 1, we're going down. So when we're always looking at this, we're looking at the blue graph, the actual thing that the shape that we're looking at. And so it's going down between that section. And with these intervals, we always use parentheses because the endpoints is a transition where it's kind of both. It kind of looks like a Star Wars ship. So between 0 and 1, this is increasing. And again, we're always looking at the x values. What is happening to the y? Where is it decreasing on the y? And then we want to know what x values that occurs for. So that is decreasing. And then let's do constant. And so constant is where it is going straight. So it's going straight from 1 until 4. And 4 has an open circle. So it kind of got covered up by my highlight here. The open circle just means parenthesis. It means that point is not included here. The only place where you may actually have a bracket is at the very end points if it stops. So if it's a transition between two things, it's always an open. But here it's an open circle, so that means parenthesis there. It doesn't keep going. So that's the section where it's going straight. So I'm going to draw my number line. And so it looks like it starts at 1. So 1 to 4. We have our graph going straight. So between 1 and 4. And then the transition point is always a parenthesis. And then 4 has an open circle. So that is a parenthesis. And so our interval for which we're constant is between 1 and 4. So you're dividing these things up. You've got multiple, like sections here. And so what I like to do is highlight the section that I'm interested in, and then I translate it to the X to that section on the horizontal number line. And then I figure out like what my endpoints are, and then I read that so I can figure out the interval notation. So you're not looking at what values on the y, we're always caring about the x here for this increasing, decreasing constant. So next one here. Okay, different graph. We want to know where we are increasing, decreasing our constant, and I am going to use the same kind of color coding. So we'll start with increasing. So where are we going up, essentially? Where is it going up from left to right? So we're going up here, and then it looks like we're getting flat, but it's technically not flat. So this is a cubic function, and cubic functions are always increasing. So this actually is increasing. It's basically going up the whole time, even though visually it looks like it does have a section that's flat. If that area was constant, we would give you the 2 points at which it was, so that you know, and you wouldn't have to kind of guess where it looks like it was flat. But this technically is not flat because it's specifically a cubic function. So this is increasing everywhere. So I do have arrows. So that means the arrows means it continues on. So it's going to continue on to the right. And then there's an arrow on the left. So it continues on to the left. So when I make my number line here, I would have just put 0 on the number line. The arrow says that you keep going. So we're going to go all, oops, wrong color. We go all the way to infinity on the right. We're going all the way to negative infinity on the left. And so when the whole number line is covered, your interval notation is from negative infinity to positive infinity. So it's increasing everywhere. So what does that mean for decreasing and constant? So if it says, well, what is decreasing, we will say none, or there will be no intervals. You need to still kind of specify that when you're asked a question like this, because you want to make it clear that you understand that there's no decrease, not that you just didn't answer it. And then constant, it's also none, because it's increasing everywhere. So you still have to kind of answer, you just write none, or there's no decreasing intervals or no constant intervals. We don't necessarily use the empty set, but I suppose you could just use the empty set that there's nothing in that interval, but that's more of set notation versus interval notation. Okay, so now here's another one, and we will again start with increasing. And so we look at the graph, and we're looking at where are we going up as we move left to right. So if I move left to right, my graph is actually, it's going down, and then it's staying the same, and then it's going down again. So there is nowhere we're actually going up as you move left to right. So there are no increasing intervals. So that means we can move on to decreasing. So if I'm going to highlight this, we actually have two sections where we are decreasing. We've got this first section right here that stops at x0, value of 0. And then it picks up again at 2. And that's where it's going down. And there are arrows at the starting point, kind of at -3, there's an arrow there. So that means it keeps going to infinity. And then when it hits, when we pick it up at 2, and then at about 4, there's an arrow. So it's going to keep going to infinity. So there's two sections here where it's decreasing. So I'm going to make a number line so I can kind of graph that. So I've got infinity, negative infinity, 0 is one of the points where we stop, and then we pick it up again at 2. And oops, there we go. Okay, so we have our number line covered from negative infinity to 0, and then we're going to put a parenthesis there because that part then becomes straight, so it's both. And then we pick it up at 2, and 2 is straight and decreasing, so I'll kind of erase that so you can see that at 2 it's kind of doing both. And then we're going all the way to infinity because we have that arrow that keeps going. So we've got two increasing intervals. So there's two ways that you can write your answer. So you could use a comma between them, negative infinity to 0 and 2 to infinity, or you can use a union symbol, negative infinity to 0, union to infinity. So it kind of depends on how, like, what Alex is letting you put in, because it will specify, it will say, like, if there's multiple intervals, put in a comma, or they'll give you the union symbol, which then says you use the union there. I usually do the union, but some books I've seen, like if you're going on a pre-calc, they want a comma. So you do kind of want to take a look at what, at least in Alex, what the options are that you're given. They're both basically correct, but you want to make sure that if they give you the possibility of entering a union symbol, you use that, because that means that that's what they're anticipating when they're looking for this. So that's decreasing. And so next is constant. And so that's the flat portion. And so you can see that we are flat between 0 and 2 right here. So, and it happens to be right on the x-axis. So I'm going to make my number line. And we've got 0 and 2. And so we are constant in that section, we're flat. And it's a transition on both of them. So we're going to use the open parentheses. So that's going to be from 0 to 2, it is constant. And we've got open parentheses there because those endpoints are both. So they can't be both at the same time. It's either one or the other. So basically, anytime that the graph is wherever the domain is of the graph, which is where it's graphed, it's either increasing, decreasing, or constant. You're never going to have something that is part of the graph and not one of these three things. These are the three choices. It can't be none of these. So you need to make sure that you have the whole part of the graph, the whole domain covered between all of your answers here. So here, our domain would be from -infinity to 4. So you need to make sure that out of all of your number lines, when you combine those onto a single number line, you have the entire domain. So you want to make sure that you're not missing any sections, basically, because you want to include the whole domain. You're splitting it up into different pieces, basically. Okay, so now different type of looking graph. And when you see graphs like this, if there's no clear circles or dots, you assume that it keeps going there. So sometimes, depending on the graphing system or the textbook or whatever, you may see that there's no symbol there. You just assume that it's an arrow unless it's a very defined dot here. And this one, they actually give us particular dots. They're labeling the X and Y intercepts. Those may or may not be relevant. It's depending on kind of what you're looking at here for your graph. So we will start with increasing. And notice that the directions here are slightly different because you could have different directions. It says, given the following graph of f of x, identify all open intervals. So they're telling you you're not going to be using any brackets. All open intervals that are increasing, decreasing, and constant. So same sort of thing, just worded slightly different. So where are we going up as we move left to right? Well, we've got this section right here where we're going up to about, that looks like it stops at x equals 0. It might be stopping a little bit before then, but we're going to use x equals 0 so we don't have to like guess a fraction or something like that. And then we're going up again at this section right here. So when I put these on the x values, I've got an arrow to the left. So that means I'm going to keep going here to infinity. And then on the right, there's also an arrow. So it's going to keep going. So we've got two separate sections here. And those are the parts where it's going up as we move from left to right. So I'm going to draw my number line. And I have to put the endpoints on there. So it looks like at x equals 0 is where we kind of stop and we switch to decreasing. And then at x equals 3, we start increasing again. So copying my shading here. And we want open intervals, which are parentheses. So I'm going to have parentheses at the two endpoints there. So we're going from -infinity to 0. And then I'm going to do the union here because that's what I'm used to. And then we're going from 3 to infinity. Those are the two sections of the domain where the graph is going up. So then we have decreasing. And so if you're looking at your graph, that's the kind of the section that's remaining here is where it's actually going down. Go to slightly different color green there. Yeah, so it's going down in that small section. So the missing section of the domain between 0 and 3 is where it's going down. So I go back to my number line that I'm going to draw. And I've got 0 and 3 on my number line. And we're decreasing between 0 and 3. And so open intervals, so we're going to be using parentheses there. So the interval notation is 0, 3. And then last is constant, and that's where it's flat, and we don't have any flat spots. So we say none. There's no spot where it is clearly flat, not going anywhere, other than there might be a little tiny thing right there, but we're going to assume that it's not, because when we give you these types of problems, we make sure that we give you problems where it's pretty obvious, where it's going flat. Okay, same directions here. Again, this type of graph, even though it looks like these stop, you're going to assume that they go on forever here. And so we're going to start with increasing. Oops, that's not the color that I want for increasing. Increasing. So where are we going up as we move from left to right? So this part over here is moving up, and then this part over here is moving up as we move left to right. And so those arrows on the left means that this is going on forever, but between x equals 0 and x equals 1, we don't have any arrows, so it's just that small little section right here where we are increasing. So I'm going to draw my number line and put my negative and positive infinity on there, and then put my 0, and then put 1, because those are the key numbers we're looking at here. And we want to put -1 as well, because that's also a key number. So we've got our graph present from negative infinity to -1, and it stops. And then it's going down from -1 to 0 on the x. And then from 0 to 1, it's going up again. And then open intervals. So these are all going to have parentheses here. So for the interval notation, I have a parenthesis at negative infinity, comma, -1, parenthesis. And then I'm going to use my union to combine it. And then 0, 1 for the second part where it is increasing. Next is decreasing. So I'm going to erase. And decreasing is the part where it is going down. So we're going down on this section and then down on that section. So we're down between -1 and 0. And then at 1, we're going to go down, and we keep going down forever. So I've got my number line. And I'm going to label -1, 0, and 1. And so we're decreasing between -1 and 0. And then those are going to be parentheses since it's open intervals. And then from 1 to infinity, we are decreasing, and another parenthesis at 1. So interval notation, we have -1, 0, union 1, infinity. And then the last one is constant, and there are no places where our graph is flat. So there are no constant intervals. Okay, so last one here, and here's an example that you would see on how the graph would look in Alex. Same thing, it says open interval. So that means even though we have a closed dot, at x equals 5. When we write our interval, we're using a parenthesis because it says open intervals. So open always means parentheses here. And so we've got increasing here. And when you're looking at this graph, it is going up basically along this whole part. So it's going up from -2 until 5. And that covers the whole graph. That's the whole domain. We don't have any parts where we're going down. We have no parts where we're going flat. So those are both going to be no. So we only have an increasing interval here. So I'm going to graph my number line. And I'm going to put -2 on my number line. And then 5 on my number line, because those are the endpoints that I care about. And we are increasing between those. And then it says open intervals. So even though it's a closed dot at 5, we use a parenthesis because it's specifying open intervals right here. And so our answer is -2, 5 here for increasing. Then decreasing, we have nowhere where we're going down, because the whole graph is going up. And then we have nowhere where we're flat. So for constant, there's also none. So this is one just like the other one that I had, where it is increasing kind of everywhere on the particular graph. So when you're doing these type of problems, you really want to, if you can, copy the problem on paper so that you can highlight these different sections so that it can aid you figuring out what you're looking at, because you're always looking at across the X, what is, you're looking at what is happening to the actual blue part that's graphed, but your answer is in terms of the X, not the Y. So you want to make sure that you're very clear. So sometimes, well, let me go to one where we have kind of both going on. Sometimes it might be helpful, make sure I'm in my highlighter, like this part was increasing. Sometimes it's helpful to highlight the whole section of the graph so you can see the X over which it's going up. And then we were decreasing in this little section. So, you can highlight the decreasing section. And then we're flat in this section right here. So you can highlight, I'm not making my highlight perfect, but you can highlight that section. And then you can kind of see on the number line the 3 different parts, because then you can look at your X-axis and say, okay, my increasing part is the yellow, my decreasing is the green, and then my constant is the blue. And you can just use the X-axis as how you're getting these different intervals. So that's an alternate way, is just to shade that whole vertical section of the graph versus, the single areas that I was doing it. Whatever works for you, but I do recommend kind of like drawing it on your X-axis at the very least, so you can clearly see what sections you're looking at, because your answers are the X, not the Y. You're not giving ordered pairs. You're giving the X values for these. So hopefully this is helpful. If you have questions, let me know. I had to reschedule this week because of a prior engagement at 4. Next week will be at the normal time, 3 p.m. And then for week 7, again, I have something at 4. So I have to reschedule that one as well. And then week 8 will be back to normal. So if you have questions, you can reach out to me, email me, use tutoring. And hopefully this is helpful. All right. Take care. Bye.